Good morning, everyone. You are welcome to Sir Joe Chemistry Class channel. Today, we'll be focusing on Neco 2026 practical, which is on titration. And the titration is acid-base titration. The acid is tetraoxobasis acid, which is H2SO4, which serves as A. The base is sodium hydroxide, NaOH, which serves as B. This question is given as a guide. A is 0.05 mol per dm³ H2SO4. B is a solution containing X gram per dm³ of NaOH. Put A in the burette and titrate it against 20.0 cm³ or 25.00 cm³ portions of B using methyl orange as indicator. Record the volume of your pipette. Tabulate your burette readings and calculate the average volume of A used. From your results and the information provided above, calculate the amount of H2SO4 in the average volume of A used. 2, concentration of B in mol per dm³. 3, value of X. And the atomic mass of hydrogen is 1. Atomic mass of oxygen is 16. Atomic mass of sodium is 23. The equation for the reaction is H2SO4 plus 2NaOH aqueous to produce 1 mole of Na2SO4 and 2 moles of water. For this titration, the volume of effect used is 25.00 cm³. Indicator used is methyl orange. Now the table for the titration is given as follows. Burette readings. The unit is cm³. Under the burette readings, we have final burette readings, we have initial burette readings, and volume of acid used. Now for the titration. For the titration, we have columns for rough titer, first titer, and second titer. Now in order to get the titer values, here we go. We have to measure 25 cm³ of base, which is sodium hydroxide, and the base is inside this reagent bottle. Now, after the base has been poured inside the conical flask, our indicator, which is methyl orange, is to be added. Thus, we are adding 2 drops of methyl orange. Now, after the methyl orange has been added to the base, now we are to pour acid inside the burette. And this reagent bottle is labeled as A N for acid. The starting point of the burette is to be set at 0 centimeter cube, and you can observe that properly with the use of filter paper. Then the filter funnel is removed on the top of the burette. Now the titration goes off, and it is expected that the color at the end point, the color will change from yellow to pink. Now the color has changed from yellow to pink, and the volume at which this is done is 27.30 centimeter cube. 27.30 centimeter cube. Now, then the measure point is 0.00. That's for the rough diagram. In order to conduct the second and the first title, in order to take the first title after the rough title has been taken, we have to measure another 25 centimeter cube of the base. So 25 centimeter cube of the base has been drawn, and it will now be poured inside the conical flask. Now we have to add two drops of methyl orange to the base. It is expected that this yellow color will change to pink as we get to the end point. Having added the methyl orange, we have to add acid. We have to add more acid to the burette so that the level of burette can reach 0 centimeter cube. Okay, So the starting point of the burette is 0 centimeter, 0 centimeter key. Then the filter funnel on top of the burette is removed. Then we can start another set of titration, which is the first titer. In order to get the titer value, the first titer value, after we have already gotten the rough titer. So the color has changed from yellow to pink. The color has changed from yellow to pink. And the volume is taken as 27.00. 27.00. So here the starting point 0.00. Then for the first tiger is 27.00. In order to get the second title, after the first title has been gotten, another base will be drawn, which means that 25 centimeter cube of base will be drawn. After the base has been poured inside the conical flask, we now add 2 drops of melted orange. Now, after the melted orange has been added to the base, it shows yellow color. Then more acid is to be added. More acid is to be added to the acid inside the burette, so that the level of the acid will reach 0 centimeter cube. Now, in order to get the second title now, you place the conical flask under the burette, and the titration continues. It's changing gradually from yellow. It's changing gradually. Okay, it has changed from yellow to pink, from yellow to pink, and the value or the volume at which the color change is taken as 27.00, 27.00. The starting point, the initial volume is 0.00, while the end point is 27.00. Now, having taken the second title, we now calculate the volume of acid used. For the rough title, we subtract 0.00 from 27.30. We have 27.30. Then for the first title, we subtract 0.00 from 27.00. We have 27.00. Then for the second title, we subtract 0.00 from 27.00. We have 27.00. 27.00. Now, with this, we can now calculate the average volume of acid used. And the formula for calculating the volume of acid used, is T1 plus T2 divided by 2. This is equals to 27.00 plus 27.00 divided by 2, and which is equals to 54.00 divided by 2 in centimeter cube. So which means that average volume of acid used is equals to 27.00 centimeter cube, which is our average volume of acid used. Now, having calculated the average volume of acid used, we move to B Roman figure 1. And the B Roman figure 1 says amount of H2SO4 in the average volume of A used. Now, in chemistry, amount is referred to mole. That is mole of H2SO4 in the average volume of A used. Amount of A used and be calculated using the formula concentration is equals to mole over volume in dm cube. Volume in dm cube. Now, by making mole or amount as subject of the formula, we now have concentration times volume in dm cube. Volume in dm cube. Which is equals to concentration given is 0.005 mole per dm cube. Then multiply by volume in dm cube. Now, in order to get the volume in dm cube, we are to divide 27 by 1000, which is equals to 0.027. By multiplying 0.027 by 0.05, we have 0.00135, which is the mole or amount. Having calculated the Roman figure 1, which is the amount of H2SO4 in the average volume of A used, we move to B Roman figure 2. Of B Roman figure 2, concentration of B in mole per dm cube can be calculated using in this case, dilution law can be used. That is CA VA over CB VB is equals to NA over NB, where CA is the molar concentration of acid, VA is the mole and is the volume. VA is the volume of acid. CB is the molar concentration of base. VB is volume of base. Where NA is mole ratio of acid, while NB is the mole ratio of base. Here we have CA is equals to 0.05 mole per dm cube. VA is equals to 27.00 centimeter cube. CB is the molar concentration of base, which is to be calculated. Then VB is 25.00 centimeter cube. That is the volume of the bed used. Then our NA from the balanced equation is 1. NB is 2. By substituting, we have 0.05 times 27.00 all over CB multiplied by 25.00 is equals to 1 all over 2. I said by substituting 0.005 multiplied by 27.00 divided by CB multiplied by 25.00 equals to 1 all over 2. By cross multiplying, we have 0.05 multiplied by 27.00 times 2 is equals to CB multiplied by 25.00 times 1. Here, CB is made the subject of the formula. We have CB is equals to 0.05 times 27.00 multiplied by 2 all over 25.00. Using the calculator, we have 0.05 times 27.00 multiplied by 2 this is equals to 2.7 divided by 25.00. And it is equals to 0.108 mole per dm cube. Mole per dm cube. This can be abbreviated as CB is approximately equals to 0.1 mole per dm cube. Therefore, the concentration of D a mole per dm cube is equals to 0.1 mole per dm cube. Now, in order to calculate Rebranded 3, which is the value of x, where we have x gram per dm cube. Value of x. So using mass concentration is equals to molar concentration times molar mass. The molar mass of sodium is the molar mass of sodium hydroxide. Molar mass of NaOH is equals to 23 plus 16 plus 1, which is equals to 40 gram per mole. And the molar concentration of CB, molar concentration of B, that is molar concentration of the base, is equals to 0.1 mole per dm cube. By substituting, we have mass concentration of mass concentration of A is equals to 20 is equal to 0.1, that's 0.1 times 40 gram per mole. That's mass concentration of B, that's mass concentration of B is equal to 0.1 times 40 gram per mole, which is calculated as thus. Yes, from mass concentration of B equals to 0.1 times 40 gram per mole, we have 4 gram as 4 gram, which means that 4 gram per dmq. Therefore, the value of x, therefore the value of x is equals to 4. That's all for today's chemistry class on Neco 2026 practical titration. Subscribe to Sir Joe Chemistry Class channel. Be blessed.